Today we're looking at lesson 6.2 in geometry, and it is on parallelograms. So first we're going to look at the properties of parallelograms, and there are 4 listed here. If a quadrilateral is a parallelogram, and a quadrilateral is a 4-sided figure, then you are looking for the opposite sides to be congruent. So they've labeled these with the 2 dashes on the left and right side and the 1 dash on the top and bottom side. So that is one property of a parallelogram. Another property of a parallelogram is that its opposite angles are congruent. And again, they've labeled the angles. And the third property of a parallelogram is that its consecutive angles are supplementary. So those are the angles labeled with X and Y. Those are next to each other. If you would add those up, those would be equal to 180. And then the fourth property, if a parallelogram has 1 right angle, then it also has 4 right angles, which then would make it a rectangle. So with that information, we're going to use that to find some angle measures. So it's talking about the parallelogram JKLM here in this particular mirror, and it tells us that the angle measure for J is 47. So we need to find angle L. Now it tells us in the properties that opposite angles are congruent. So that would make angle L also 47. And then another thing it tells us about the angles is that consecutive angles, which are next to each other, are supplementary. So for angle M, we need to take 180 and subtract 47 to get the measure of angle M, which is then 133. Now, if it's asking us and saying that suppose the arm of this mirror was extended even further so that angle J is 90, what would the measures of each of the other angles be? Well, that would make all the other angles 90, as the last property has stated. Then there's a few properties of the diagonals of the parallelograms, and diagonals are where the vertices connect that are non-consecutive. So like AC and BD in this figure. And it says that if a quadrilateral is a parallelogram, its diagonals bisect each other. And then that's going to create equal parts. So these 2 are equal, these 2 are equal. And then if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So if we take each diagonal separately, these 2 congruent triangles are ABD and BDC. So with that information, we're going to find some values of x's and y's here. So the first one, find the value of each variable in the given parallelogram. Well, to find the variables where you have the x's, we have 2 consecutive angles here. So we know that those add up to 180. So we're going to do 4x plus 2x minus 6 equals 180. And that's how we're going to get x. So that gives us 6x minus 6. We get 6x equals 186. So x would be 31. Then, for the y's, those are opposite sides. We know that based on the first 4 properties, that opposite sides are congruent. So we're going to put y plus 8 equal to 5y. solve for y. So y is 2. Then, if we're going to do the second parallelogram, it asks us to solve for z. And these are talking about the diagonals, so those diagonals bisect each other, which makes these two parts of the diagonal equal. So we're going to do 3z plus 4 equals z plus 5. And that will give us our final variable. Solve for z. So we get 2z equals 1. We divide by z. And to find the intersection of the diagonals, really we're just looking at the midpoint of SU and the midpoint of TR, which should be the same. So we just need to find the midpoint of SU. And the midpoint formula, just in case you forgot, is adding up the x's, divide by 2, comma, adding up the y's, divide by 2. So the x values of s and u are negative 6 and 4. And the y values are 7 and negative 2. So we get 2, or negative 2 over 2, which is negative 1. And 7 plus negative 2 is 5. 5 over 2 is 2.5. So our midpoint is negative 1, 2.5. Which is, if I had it a little bit straighter, that would be exact. But negative 1, 2.5. And that would be where they would cross. The last one is we're going to write a 2-column proof here. We have 2 parallelograms. We need to prove that HJ is congruent to ML. So we first can say that, well, they're 2 parallelograms. That's what our given is. So we write that. And notice the parallelogram symbol is just the symbol. It looks like a little bit of a slanted rectangle. And then we can say the opposite sides of them are are congruent. So HJ and PK are congruent. And PK and ML are congruent. And that is going to be based on one of our first properties, which is theorem 6.3. And then if we remember and take out the middle, that's called the transitive property. We could put HJ is congruent then to ML, which is what we're trying to prove. And we're all done. And that's the transitive property. Oops, I'm not sure where this cut me off, but if you can see here, this is only a 3-step proof. You have the givens, which is telling you that it's parallelograms. Then you have the property of theorem 6.3, which says the 2 opposite sides are congruent to each other. Excuse me. And then you have where you can take out the middle since both are congruent to PK, and that's called the transitive property, which gives us what we're trying to prove. HJ is congruent to ML. And that concludes lesson 6.2 on parallelograms.